Okay, here we go for this assignment. It's going to be out of your textbook here. It's pretty straightforward. You're just going to be looking at formulas that involve exponential growth or exponential decay, pretty much exponential functions. So what it is, it's the formula. The formula is given. All you have to do is put all the numbers in the right place, do the calculations. Obviously, you're going to use your calculator, and that's it. And I'm using the book because the way that the examples are there, they're presented. It's all pretty much presented very clearly. So hopefully, this isn't too bad. Okay. So I'll just go over a couple of things, and for the most part, like I said, look at the examples in the book, look at the formula, you substitute the numbers, do the calculations, and you'll get the answers. All right, so this is from chapter 3.1, and again, if you don't have you should have a hard copy of the book, but if you don't have your book with you, then you should be able to access your book online as well. So no excuses that you didn't have your book. You can access it online. Okay, so go to chapter 3.1, and right, we've been working on graphing exponential functions, right? But we're moving on to actually looking at real life applications of these exponential functions. So when you look and you finally turn over to page 162 here, page 162 will have this formula here. So I'm just going to kind of go over what the formula is, and the examples here following. There's actually, from this formula, they're using an example, and there's 3 parts, and I'll explain why there's 3 parts. Okay, but let's look at this formula first for compound interest. Okay, so the formula is given. Oops, let me zoom this in. The formula is there. I mean, you can use it. You don't have to memorize it. Just know the numbers, where the numbers go and how they need to be there. Okay. All right, so don't just read it and then say, I didn't get it, and then just fly by it. Some stuff you need to read and then maybe read again and read several times until you understand what every part means. Okay. If principal P stands for principal, not principal like Mr. Balderas, our high school principal. No. Principal is talking about like the money. Whatever money you're going to be investing or you're going to put into this account, or that's what the principal, whatever this is your P. If principal P is invested, so where do you put that money? Well, right here for the letter P. If a principal P is invested at an annual interest rate, and the interest rate is the letter R, which you see right there. There's one little R. But this interest rate, when it's a percent, you have to change it into decimal form. If you see, it says right there, the interest rate R has to be in decimal form. So they're going to probably give you a percent. So your interest rate for R, when they give you a percent, you cannot use the percent. You got to change it into decimal form. So let's say if I have 25%, right? If the problem says it's 25% or whatever, then how do you change that to the decimal form? Remember 25%, well, the decimal is here. You got to move it back. You got to move it back twice to the left. So that would be in decimal form would be what? 0.25. Yeah? How about if it's 12%? Some of your credit cards are actually at 16%. 16% interest rate that they're charging you. Well, let's say if it's 12%. Well, 12% would be what? Well, if it's 12%, the decimal's here because it's a whole number 12. You move it back twice. That'll be what? 0.12. Right? Change it to a decimal. Don't use the number 25 or don't use the number 12. Don't use the percent. You got to use the decimal equivalent. What if you have like 6%. Something like 6% would be what? Well, 6 is just 6. But if I got to move it twice back, it would be what? I have to move it twice, right? You got to move it 2 times over to the left. That would be 0.06. Okay, so whatever, they're going to give you an interest rate. They'll say a percentage for this, for the interest rate for R. But see, it's telling you right here, it has to be in a decimal form. Okay, so that's kind of what I'm talking about right here. If it's 25%, don't use the number 25. You got to use 0.25. You got to use the decimal. If it says 12%, don't put 12 in the formula. You got to use 0.12. If it's something like 6% or any single digit like this, you got to move it twice over, so it's 0.06. What if it's something like 1.3%? Well, you still got to move it over 2 times. Remember, that's, you see the pattern. All of them you're moving over 2 times. You got to move it to the left 2 times. So that would be what? 0.013. Right? Because I move it once, and then another one, I got to put the decimal here, so it's 0.013. Okay, so this R value has to be in a decimal form, right? Because if you look at this formula, there's a lot of letters. There's a P. I need to get, A is for your account. What's your new account balance, right? That's what's in your account. P is for the principal. That's how much you're initially investing. 1, well, you already know the number 1. Leave it. It's always constant. R is the interest rate. That'll be a decimal. And there's 2 N's, and this is the one we're going to talk about a little bit more. N is what? The number of times it's compounded. This is where you have to be careful. The number of, I'm sorry, let me take that back. The number of compounded N times a year. How many times is it compounded a year? Okay, so this is where some of you, if you put this wrong number here, this is the one that's going to trick you. The value of N. I'll come back to N, and you're going to use it here and you're going to use it here. And then obviously the last one is T, and T is like for time, but this time is not in minutes. It's not in hours. Your time is in years. So they'll probably give you I don't think you're going to have any issues with the time or with the rate. You're going to have issues with the value of N. So how many years? How many years are you going to leave this money in the bank? Or how many years, let's say for example, when they put trash in the ground, how many years does it take for it to decay? Stuff like that. Okay, so different disciplines, sciences, and obviously math applications, real world statistics, economics, banking, like I said, credit cards. They all have formulas. The formulas are, they're already set for you. The question is, if I give you all the information, pretty much that's what's happening here. If you're given all the information, can you put that in this formula and figure it out, calculate it out? Okay, that's what's happening here with these problems. So pretty much you're just gonna substitute all these. They're gonna give you the P, they're gonna give you the R, they're gonna give you all these. All right, and just substitute it into this formula. There's other formulas, right? There's gonna be, this one's just for compound interest. Okay, but they're asking you for compound interest, you use that one. There's gonna be another one where it's asking you to continuously, a continuous compound interest will be this simple formula here. But again, principal is P, R is the interest rate in decimal form, A is the account, the balance, or the account balance. A, account balance. After T, time is in years again. So they actually get easier. And they show you an example here, right? Because you're actually going to see word problems. You're going to see these word problems right here. Let me focus this right. This is in your book. I'm looking at page 163, 162, 163. Okay, so let's just look at this one real quick and I'll go back. This one's easier. This one, the formula is A is equal to P, your principal. E is a value on your calculator. Where is that? Where is the value E? Right here, you guys. Right here, see? E. See the little letter E? It's usually next to the logarithm button or the natural log, the ln. That's the value of E. E has a specific value, but that's that value there. R is the rate, again in decimal, and T is time. So if you read this one, so what do I need? I need P, R, and T. E is a value on your calculator. I need P, R, and T. P is the principal. Suppose Christy finds an account that will allow her to invest $300. That's your P. P is $300. And if you see here, P, they even put it in color. In red, P is 300. See, that's why it's 300. E is a value on your calculator. I just showed you where it is. Now, what's the rate? $300 at 6%. Oh, I just did 6%. Remember, you can't put 6. You got to put what? Move it over twice, so it's 0.06. So I got to focus in so you can see this here. See, there's a rate 6%, but they didn't put 6. They put, right, it says 6% right here. But in the formula for R, which is right up here, they put 0.06. See, they don't put the number 6. You got to move the decimal twice over. And then T is time. Well, if they put 20, I bet you it says 20 years. 6% compounded continuously. Oh, compounded continuously tells you use this formula, right? Compound, continuous compound. That's how you know you use this one. Okay. If there are no other deposits or withdrawals, what will be Christie's account after 20 years? See, that's your time. And that's why it's a 20. But this one's straightforward. This one's straightforward. You put everything in the calculator. And this value of E, again, is right here. You see. Oh, let me get this out of here. Again, it's usually next to your right here. So if you want to know what it is, it's like 2.71. It's a constant. E to the power of x. So if I do, I bet you look. Second function E, and then to the power of 1 to tell you how much that value is. E to the power of 1. If x is 1, e to the power of 1, it's like 2 point. Yeah, there it is. 2 points. That's the value of E. Okay. But if you're doing this problem like this, well, you enter all of this in the calculator, right? And again, I'm telling you, here the example's pretty straightforward. I mean, it's just a formula, and you read the problem, you get all the information from the problem, and then you substitute it in. Okay? So let me stop this video here, but I want to go back to this problem, which I'll do in the second video, and talk more about what's going on with this one. This one's the one that's a little bit more complicated, but it's actually still easy. Okay, let me stop this one here, and then look at the second video.